Good afternoon. You should have by now work to fill out this table. So what we're looking at is the expanded or the standard form for a quadratic, and then how it can simplify to what's called a perfect square binomial. These would be perfect square trinomials. So recognizing that this quadratic of this form would always create a binomial squared, or it's the same factor repeated. Okay. So what I anticipated would happen is the first 3, 4, 5, 6 rows are pretty easy, and then those last ones are kind of tricky. So let's take a look at that. When you had like x squared minus 20x, we didn't know what to put here. From before, we see that this constant that's in the binomial, it's always half of whatever the b value is. So that's where here I got 10, because it's half of 20. And then if I know this, then if I were to FOIL x minus 10 times x minus 10, negative 10 times negative 10 becomes 100. So it's almost as if you have to jump over to this part first, and then you can go back and fill in this piece. Okay, so that's what I did here. I knew that I had to take b and cut it in half, or divide by 2. So this value, no matter what b is, would always be b over 2. And then if I square that, b over 2 times b over 2, I get b squared over 4. So how that relates to this last one, I would take 7 divided by 2, so 7 halves, and then square that, squaring the numerator and denominator, gets 49 fourths. I know you can write these as decimals, but I'm telling you it's going to be a lot easier if you leave it as a fraction, especially as our ratios get more complex. So have that in mind for what we're going to do in a few minutes. But let's say you're solving x minus 2 squared equals 25. Okay, what we were doing before was solving by factoring, so we're going to solve using that method, and then we're going to solve using what we saw yesterday with the square root property. So solving by factoring meant that we needed to get the equation equal to 0, and then factor the quadratic, and then set each factor equal to 0. So to do that, we would have to expand the left-hand side, okay, by FOIL. So x squared minus 4x plus 4. Okay, the light turned off. Hold on. There we go. Okay, and then we would subtract 25 from both sides. So x squared minus 4x minus 21 equals 0. Okay, to solve by factoring, we're using the zero product property. So you set the equation equal to 0. From here, you factor to x minus 7, x plus 3, and then set each factor equal to 0. So our solutions would be 7 and negative 3. And I ran out of room there. Using what we learned yesterday with the square root property, as long as it's a single quantity squared, we can square root both sides. And what that would get us is x minus 2 equals, and then when you square the right-hand side, you need the plus or minus symbol. So plus or minus the square root of 25, which is 5. And then add 2. 2 plus or minus 5. So 2 plus 5 is 7. 2 minus 5 is negative 3. Looking at the work that we had to do for these, okay, this would be a whole lot less work, right? We did it in like 2 steps and it was really easy. You can solve by factoring, but it is a little bit more hassle because you have to expand, move terms, factor, set each factor equal to 0. So unless a problem is designed or set up to be like equal to 0, or it's really quickly can get to that spot, square root property is the way to go. It's really a lot more efficient. So now the question comes, well, can we use the square root property on everything? And the answer is yes, as long as you can use this pattern from above to write any quadratic as a binomial squared, as a perfect square binomial. So let's say we have x squared plus 12x plus 32 equals 0. Okay, this is not a perfect square trinomial because it's not like the same factor squared. So what we're going to use is something called completing the square, which is the process that we did from above. And what it looks like is we're taking the first two terms, the quadratic term and the linear term, and we're just using those as our pieces. And we're going to fill in a missing value to make it a perfect square trinomial. In the meantime, we move the constant to the other side. So the original c value, we're going to subtract. Okay. All right. From here, if you ignore this side, this is the exact same work that we were doing above. Okay. So you need to figure out what would go in that missing hole to get it a perfect square. So we know our next step, we want it to look like a binomial squared. Okay. I know that first times first tells us the first term is x. And then because it's a plus 12x, I know it's the addition sign. So how we find this is that it's always going to be half of the b term. So half of 12 is 6. And now that I know what the binomial or the perfect square binomial looks like, I can work backwards and figure out what would have to go in this spot. So x plus 6 times x plus 6 would be x squared plus 12x plus 36. So it's this number squared would go back up here. So we did kind of a two-step here where we dropped down, found that second term of the binomial, and then squared that to find the missing piece. We can't just add 36 and say it's the same equation. We need to keep the equation balanced. So if we added 36 to the left-hand side, we're going to add 36 to the right-hand side. Okay. So we have rearranged some terms. We moved 32, and then we filled in a missing piece to make the left-hand side a perfect square trinomial, which now is written as x plus 6 squared. And the right-hand side, we can now write as 4, negative 32 plus 36. Okay, we just took something that was not a perfect square trinomial and wrote it like one so that we can use this square root property. Okay, from here, it's really easy that we just square root both sides. So x plus 6 equals plus or minus 2. And then subtract 6. So we have x equals negative 6 plus or minus 2. So our solutions are negative 6 plus 2, which is negative 4, negative 6 minus 2, negative 8. Okay. So this process is called completing the square. In words, what we did was move the constant to the right-hand side. So the constant in this case was 32. We moved that to the other side by subtracting 32. Step 2 is to find a value for c such that you make a perfect square trinomial. Find a value for c so that the left-hand side is a perfect square trinomial. From there, you factor. Okay, x squared plus 12x plus 36 factors to x plus 6 quantity squared. Okay, it should be a binomial squared. And then from there, you use the square root property like normal. Okay, these steps explain what the process completing the square looks like. I want you to think about why we call it completing the square, and we'll talk about that on Friday. For the rest of the period today, what I would like you to do is turn this worksheet over for more practice. Okay, so to start, I've got some that are kind of fill in the blank with those steps, and then a couple that you can try on your own with completing the square, and then there is a challenge question. And then after that, you have some time that you can work on the reflection for brain drain, and then you can study for your concept check that is tomorrow. Okay, good luck. Email me with questions.